Okay, good evening everyone, and welcome back to another episode of Science at Home. You Tonight we're gonna talk about the moon, um, and this is quite fitting because, as you know, it's the 50th anniversary of the Apollo 13 doomed mission to the moon. And so I'm gonna talk to you about a bit what the Apollo program actually did on the moon and what we learned from it. And of course, I'm going to ask you a bit of questions together with my daughter Morgana. And just as a reminder, please do ask questions at the end of it. I will be online on the Facebook chat to answer any of your questions. Okay, so let's start. This is a fantastic picture of the moon taken from space. It's a bit massaged, but essentially it shows you what an eclipse will look like if you were above the clouds. So obviously the moon has been around for a long time, and through the spans of humanity, it got embedded in our myths and religion. In Ireland, there are evidence of a possible stone calendar that is related to moon symbolism near the River Boyne. And also, just as a reminder, as we're approaching Easter, that Easter actually falls on the first Sunday after the first full moon after the vernal equinox. So basically the first Sunday after the first full moon after the 21st of century. And of course there are many other examples of how the moon enters the myths and religions. So my first question to you, Morgana, where have you been? Were you still around? Yes. So which one was the god or goddess of the moon in ancient Egypt? Was it Anubis, Ra, Bastet, or Khonshu? Khonshu. Well, actually, you're quite lucky for having, just guessed. Yeah, so Anubis was the Jacob.
It is Khonshu.
Yeah, it is Khonshu. Yeah, Ra is the sun god. Bastet is the god of the cats that you love a lot. So humans have always fantasized to travel to the moon, which we actually did 50 years ago. But long before that, people wrote novels, shot movies, or drew comics books. So these are three examples. For instance, A True History was a satiric novel by Lucian of Samosata, which was written into the 2nd century BC. You may remember the silent movie by Georges Méliès in 1902, where people were just shot on inside a cannon on the moon, and then the famous On a marché sur la lune by Hergé of The Adventure of Tintin. Now, when it comes to the first scientific measurements about the moon, notable was Aristarchus of Samos, who in 270 BC first estimated the distance of the moon to be around 60 Earth radii during a lunar eclipse, using the timing of.
What is that?
That's a lunar eclipse. So what you see here is the moon as it crosses the shadow. You see these round shadows? This is the shadow of the Earth. Later on, Eratosthenes of Cyrene will estimate the radius of the Earth, and that will allow you to actually work out the true distance of the moon. Now, as earlier this week our director Michael Burton was explaining, the moon was the first object that Galileo looked at through the eyepiece of his telescope, and this was a very important observation because it shows for the first time that the moon is not such a perfect object, that in fact it has mountains, valleys, and craters. And later on he also discovered the phases of Venus and the moons of Jupiter that basically proved that we don't have all the planets and the sun going around us, but it's the planets that go around the sun. Now let's go back to the moon and let's just review some basic facts. First of all, the size. Well, the moon is roughly 3,500 kilometers across, which is 4 times smaller than the Earth. If you want to picture this into your mind in an easier way, it's like comparing a tennis ball to a basketball. Now, although it's only 4 times smaller, the moon is 100 times less massive than the Earth. Thus the moon also has a much weaker gravity. The moon goes around the Earth on an orbit that has a radius of roughly 384,000 kilometers. If you want to take again the analogy of the basketball and the tennis ball going around it, then you will have to put the tennis ball, far away from the basketball in such a way that you can place 30 basketballs between your basketball Earth and your tennis ball moon. And what about the orbital and rotation periods? Well, these are basically the same. The moon goes around the Earth in 27 days, and it also goes around itself in 27 days. This means that we only get to see only one side of the moon, and the other side is known as the far side. And here is the first question for you again about the moon. Taking into account that the gravity of the moon is 17% that of the Earth, as an average person, how high could you jump on the moon, Morgana? 1 meter, 30 centimeter, 3 meter, or 10 meter?
3 meter.
3 meter. Wow, that's why very well guessed. Okay.
Is it 3 meter?
Yes, it's 3 meter. Well done.
Yay.
Yeah. So let's move on to the next slide. And let's talk about the Earth and the moon as a system. You may think that, the moon is just one moon like the other moons in the solar system. But in reality, our moon is pretty special. That is not to say that it's the biggest moon out there. The moons of Jupiter are even bigger, most of them, than the Earth, the 4 Galileo moons. But they are much smaller than Jupiter. So most planets, all the planets except the Earth, they have smaller moons, much smaller moons compared to themselves than the moon does compared to the Earth. What do you want to say?
The Earth is bigger than the moon now.
Yes, of course it is bigger than the moon. It's 4 times bigger and 100 times more massive. The only planet that is an exception to this, but it's no longer a planet, is Pluto, who has a big moon compared to itself, which is Charon. Now, this is a very special arrangement that we have here, and it proved to be very important. My next question is to you is, why does it matter that the moon is so relatively massive compared to the other moons? It protects the Earth from asteroids. It keeps our climate stable. It keeps the Earth on its orbit. It helped with life's evolution on land. What do you think?
He helped the Earth.
The what? It helped the life? Yeah, okay. So, yes.
Is it?
Yeah, both of them. It is true that it helped with the life's evolution on land, and it also keeps our climate stable. Yes, it is. And the reason why is this is because otherwise, the Earth will rotate around this axis, and this axis will actually start to wobble around without the moon. That's precisely what happens to Mars. Mars does not have a big moon. It has 3 little moons, 2 little moons, very little compared to Mars. And essentially Mars, in fact, wobbles. So every 10 to 20 million years, its rotation axis moves from between 40 and 14 degrees, whereas our Earth has an inclination is over just 27 degrees and is more or less the same. And this is very important because it keeps the climate fixed. Whereas you could see in this picture here that when the obliquity of Mars changes over time, then the ice caps can extend much further south or north away from the poles. So the climate actually is much stable on Earth thanks to the moon. And that actually helps if you want to sustain life. But the fact that it's also this big means that on Earth there are tides, very big tides, compared to other planets. And this is important because it allowed for the species that were living on the in the sea to try their way out slowly and steadily to colonize the ground, so the earth, because they could live in between the area where you have water and just a dry earth, dry ground. So how did we come about this special arrangement? Well, this is a story that is related to the formation of the whole solar system. And it turns out that, the moon indeed holds very important clues to how the solar system formed. And by studying the moon, we can actually understand a bit better how the moon formed. This is, if you want, is the main scientific reason why we went to the moon and why also, the Russia was trying to go there. That was the scientific reason. In reality, the reason why we went to the moon was political. It was basically a show between Russia and the United States to display who had the mightiest rocket capabilities and who was most technologically advanced. And we should not, in this respect, forget that the Russian really led this game, the so-called space race, for quite a long time. The Russians were the first to send this satellite here, you see, the Sputnik, in orbit in 1957. They were the first to send a man in space with Yuri Gagarin. They were the first to send a satellite around the moon on the far side and take the first picture of the far side. And after the United States landed the first man, they were also the first to actually land an unmanned robot.
I like that robot.
Oh, you like the robot? That was called Lunokhod.
I like that robot.
But let's go back to the science that the astronaut did when they went on the moon. You want to hear about that? Yes? Okay. So I will have to make some choices about this. But first of all, let me tell you one thing. It's not actually easy to do science on the moon because of the different gravity, right? So let's see an example of this.
Hey, John, while you're sampling there, you might look around and see if you see any vesicular basalt.
That's what I'm looking for.
Good show. I told him you were.
Whoop! Okay.
We see that one went all the way in.
Not quite. But there it is, all but about 5 inches.
Okay.
And that one was smooth.
Okay, and John, stand by for a feed water tone.
Just got it.
So as you can see, it was quite difficult to move on the moon. And so quite a lot of mistakes actually
Quite
happened.
difficult to get up.
Yeah, to get up. Yes.
Why?
Yeah, because there was less gravity, so everything is a bit more difficult because we are not used to move on that gravity. Now, let's learn about what we learn from the science experiments. One very important experiment was rock sampling. There's a lot of rocks that were brought back to Earth. These were analyzed, and it was found that the rocks of the moon are pretty old. That indicates, for instance, that the moon formed around 4.5 billion years ago, so pretty much at the same time or shortly after that the Earth formed. So that's a very important clue. Furthermore, it turned out that, the rocks had very similar isotopes to the composition of the oldest rocks on Earth. In other words, this means, wait, Morgana, this means that the moon...
I want to press the button.
Okay, you press the button when I tell you. Okay, in other words, that means that the rocks are genetically related to the Earth's rocks. So maybe, there's a link between the formation of the moon and the formation of the Earth. Okay, next slide, press the button. Okay, so then another experiment they did is that they put these laser ranging retroflectors. And
What
that
is laser reflectors?
retroflectors. So basically, in conjunction with the McDonald Observatory, this demonstrated that the moon is actually moving away from us. This was done because at the McDonald Observatory they were shooting a laser up to the moon, which was reflected back by this mirror, and then by timing the delay between the time they sent the laser beam and they were getting it back, they actually saw that this delay was getting longer and longer, meaning that the distance between the Earth and the moon was increasing. And here's my next question to you. So the moon is moving away from us, but by how much per year? Does it move by 89 kilometer per year, 2.5 kilometer, 3.8 centimeter, or 1.1 millimeter, Morgana?
1.1.
Millimeter? No, it's moving by 3.8 centimeter.
I did say that.
No, you did say 1.1 millimeter. So now what they did also is that they took a lot of pictures of the moon, really accurate one. And what they found is that there are lots of craters, small craters within bigger craters, and then these bigger craters are even inside even larger crater. That means that these small craters, they form after the big craters. Alright, so this tells you about the history of meteor bombardment, so you can clearly tell that this big crater formed before and then came the other ones. But when exactly did this happen? For this, you need to go to these craters, take rock samples, and actually date them from Earth on your lab. And this actually is something that is still going on because we are still analyzing all these rock samples. So once we know exactly, how we know very well the dates of all these craters, then we can finally understand better the history of, how many asteroids were running around in the early solar system, and now there are less, and how fast they got gobbled up by the planets and moons as well. Another experiment that was done was that they placed some seismographs on the moon, and although the moon does not have volcanic activity presently or any tectonic activities, there are still small moonquakes. And so that shows that the moon is stratified like a planet. It has a crust, a mantle, and a core, which is a bit hotter. And at the same time, this seismographer, they also picked up little irregular seismic vibration that were coming only from time to time, and they were much smaller, and this actually allowed to detect asteroid impacts that were maybe happening on the other side of the moon from the place where the seismographer was.
Is that an asteroid?
Yes, I'm coming to that. Now, what is the current theory? If we put all these pieces together, what is the current theory for the formation of the moon? Well, the best theory that we have at the moment is the one that seems to agree with most of facts that I've outlined, so that the moon is very old, that the rocks on the moon in reality are very similar to the oldest rocks on Earth, and also that we have very big impact craters, and then we have lots of small ones, and also I should say that there are regions that are flat that we call the mares, where we had basically oceans of molten lava that then cooled down and became what we call the gray part, dark gray part that you see on the moon. It's the theory of the giant impact theory. So the idea is that there was maybe a Mars-sized planet that actually was orbiting more or less at the same distance as the Earth from the Sun, and this little hypothetical planet has now been called Theia, and it impacted on Earth. It shattered itself and also a lot of material from the primordial Earth. This material formed a ring around the Earth, so maybe the Earth at some point was a bit like Saturn, And then these little pieces of rocks that were in this ring around the Earth, they actually got together and they formed the Moon. So, to conclude this talk, I'm now going to show you a nice movie. That's the impact. Okay, I'm going to show you now a nice movie by the Lunar Reconnaissance Orbiter mission, and which also looked into, in particular, at the craters and the craterization. So how many craters formed earlier and afterwards. And it turns out that after this big collision and the formation of the proto-moon, then to get to the present appearance of the moon, well, what you need is that you need to have had a very intense phase of asteroid bombardment a long time ago, some 3 to 4 billion years ago. And then after that, the bombardment was more gentle and steady. And then now the bombardment of asteroid is quite small. So this concludes our talk. Now I'm here to answer questions if you want on the Facebook chat. Good evening.